Okay, so today, one of the things that can be different about today is you'll be doing the rational root on a problem, which is that f con over f co thing. And you'll notice that, wait a minute, there's no constant. If there's no constant, I mean, that's at the end there where the red arrow is. What is the constant then, really? 0. And so then you got to do f con over f co. On your scratch paper, I'd like you to figure out what that really means then on your scratch paper. What are the possible roots? That's what the rational root tells us, is what are the things that are possible. Tell me, what are the possible roots in this one? Well, I know it's 0 on the top, but what do you mean by 0 when you say 0? What are the factors of the coefficient? That's this thing. 1 and 2 and 4. Okay, so the answers are, well, what's the answer? I mean, this is partway through the problem. What's the answer? 0 divided by 1 is what? 0. 0 divided by 2 is what? 0 divided by 4 is what? 0. So then the only thing that we can check is 0. That's it. Now, granted, there are other factors of 0 if you really think about it, because 5 times 0 is 0. So 5 is a factor of 0. Isn't that weird? And 23.8 is a factor of 0 also. That's what I'm trying to get at. There's a bazillion things that could be factors, but the only one we can figure out is whether 0 works. And if 0 is a factor of something, that means that x plus 0 would be the factor for it, right? So 0 is a root, or not. So when you're factoring that out, you're really, x plus 0 is the same as just factoring out an x. And if you think about that, that just means factor an x out of everything. You see how that gets a lot easier as soon as I factor an x out of everything? I end up with 4x to the third. Sorry, x comes out to the front. 4x to the third plus 6x squared plus 4x plus 3. And now it was a 1, 2, 3, 4 termer. It's still a 1, 2, 3, 4 termer. But it's a lot simpler because it's got an x factored out to the front. And now these numbers are all smaller, and now I can do factor by grouping. Another thing, if this had been a 5 term, anyway, I'll show you on a next slide how that makes even more sense. But by knowing that x factors out to the front, I've already got one of my roots, and now it's a little bit simpler. And then I can keep factoring it from here, and I can see if factor by grouping will work. And if it won't, then I have to try some other technique. Yes? So 0 is a root, exactly. But, so what I'm trying to tell you is that as soon as you notice that your equation doesn't have anything at the end here, see? Oh, look, no root. Then, or no constant. Then you know 0 is a root. It will work. Because that means if there's nothing here, then that means that there must have been an x in everything. And if there's really an x in everything, well then x will be able to factor out of everything. And therefore it will be a 0. So you don't need to go through the whole synthetic thing. You don't need to do the rational root even. So whenever you see these, you've just saved yourself a ton of time. Because as soon as you notice that the constant is 0, then you know that everything has an x in it, and you can just factor out an x right off the bat. All right, here's the next thing you got to know. This is the new thing. Ooh, look at my spinny new. I learned a new trick. Okay. How many terms does this one have? 6. And remember, this is the hardest factoring that you do at the whole high school. Seriously, you don't do anything harder than this. I'm not saying there's not harder topics, but there isn't any harder factoring. So, what do you do with 6? You know what? You just do the same exact thing. F con over F co, use a rational root to figure out what could possibly be roots. Then test them using synthetic. Then after we tested it and we found one that works, then we've got it factored down. And it won't be a 6 term anymore, then it'll be a 5 term. And then we do rational root again on the 5 term one. Exactly. You're using everything you've learned, and you're exactly right. the homework on this for today. There's a few of them that are the kind where the constant was 0, like I showed you, and the answer is 0. Done. You know, you factor out the 0, and it's easy. So there's only like 2 problems today, but they're like this. All right, so I'm going to show you one, and then I'll have you try one. All right. First of all, rational root f con. Actually, you know what? Instead of you having to do one later, let's do this one with me, and then this will be our last one that we do. Okay? Everybody, on your piece of paper, you don't even have to rewrite the original equation. We'll just start with f con over f co. Write that. What are the factors of the constant? 1 and 2. What are the factors of the coefficient? Coefficients, this one. 1 and 2 and 4. That's plus or minus of each one. Then we take each one divided by each one. So what's 1 divided by 1? 1. What's 1 divided by 2? 1/2. What's 1 divided by 4? 1/4. What's 2 divided by 1? 2. What's 2 divided by 2? 1. And we already had that one, so I don't have to write it again. What's 2 divided by 4? 1/2, and we already had that one. So there's my list of possible things that could work. Do you think I did the fraction to you? No, it wasn't that mean. So it's either 1 or 2. Any guesses?
2.
You're right. It's 2. Let's check 2. 2. Just check 2. How do you check it? Well, you go like this. And thankfully there weren't any placeholders, otherwise you'd have to use that. And just like Drew said, we're going to have to use everything we've learned. We'll have to use synthetic and rational root and factor by grouping. Uh-oh. Oh, it's a -2. Phew. Okay, a -2 plus 2 makes 0. Yay. So really, what are we doing, though? We're factoring. And so now we got to rewrite this puppy. Everybody write it. I'm going to call on one person to tell me what the answer is. I'll pause for a second while you do that. Okay, so it's 4x to the what? 4th, plus 6x to the 3rd, plus 4x to the 2nd, plus 3x plus 1. Is that a -1? I think it's plus 1. Okay, and then, am I done factoring? No. You look at this one, and you do rational root again, and you got to look at the factors of the constant or the factors of the coefficient. And okay, I'll help you. What's the factors of the constant? That's easy. 1 over what's the factors of the coefficient? 1 and 2 and 4. And it could be 1 over 1, which is 1, or 1 over 2, or 1 over 4. And it's not likely I would have done the fractions to you, and therefore it's probably the plus or minus 1. What do you think it is, plus 1 or minus 1? Check -1. Okay, we'll check -1. Here's a neato tip that a kid in one of my classes figured out. He said, you know what? It has to be a negative that it goes in here, because all of these are positive, and therefore it has to be a negative in the problem somewhere to get it to cancel all out at the end. So yeah, you're right. If they're all pluses, then you'd better be testing a negative root. Okay, so we've tested and we found that that worked, and so now don't forget about this root. That's still part of it. And then there's this root, and that's x plus 1. And then there's this part here, 4x to the 3rd plus 2x squared plus 2x plus 1. And then what would you have to do? Factor by grouping. Factor by grouping. So I have to break that in half. Final answer, x minus 2, x plus 1. I think I did this factor by grouping like twice, and I think it comes out to 2x plus 1 and x 2x squared plus 1. Thank you. Whew. All right. Then, if they asked you what the roots were, you'd say the roots were 2 for that one, -1 for that one, -1/2 for that one, and this would be imaginary roots that we talked about doing before. All right, so you can see how this encompasses a tremendous amount of stuff that you've learned how to do. All right, that's it.